Hello friends, welcome back to the bench. Our patient today is a 2005 Subaru Outback. Was it? Let me just pull up the ticket actually. Yes, 2005 Legacy. This is GT, so this is turbocharged engine. And normally that doesn't matter, but in this case it matters whether it's an SO or DO version. And I'll show you in a second. First, what's wrong with it? Fan circuit is always on, and this is fan circuit number 2. There are 2 fans that cool the engine or the radiator, and the way customer describes it is as soon as you turn on the ignition, the fan just goes full speed. And that kind of threw me off, that description, because I thought we were talking about the internal fans in the car, because it goes full speed, right? So I was looking for the output that would be PWM output from the ECM, because that's gotta be it, right? And if we have a short on PWM, then we don't have the ability to control RPM. But in this case, there's no RPM control. There's a relay that opens the or closes the circuit, and that turns on the fan. And if it closes, the fan turns off. So, or if it opens, the fan turns off. So it's simple on-off switch. There's no speed control on it. So that that kind of threw me off for a bit, but luckily I got some assistance from the other technicians, and they kind of pointed me in the right direction, meaning like, yeah, the ECM doesn't control the fan inside, so you don't need to keep looking. So it's either those 2 fans or it's not ECM related, and yeah, it's the one of those fans. So let's give it a quick visual. Alright, visual inspection doesn't reveal anything. So let's grab this is SO, this is DO. So the majority of pinout is the same on SO and DO, but the fan circuit is different. That's one of the few differences. That's why I have 2 of them printed. And we're looking for a radiator fan relay. Radiator fan relay 2 control. We are on B13524. B13524 is this one. So this pin should be shorted to ground. If it is, how are we going to find which chip is responsible? I was hoping this would be a transistor based, but I was a bit too optimistic. And that's like years 2002, 2001, those models. This one only has 2 transistors, which are used as linear regulators for 5 volts and 3.3. That's why they're on the heatsink. But what we will do is just inject some voltage and analyze the thermal image. And that's how we'll find which component needs to be replaced. And it's likely one of these 2. I see 601 and 602, or not. It could be because it's a simple fan control. So it's pretty much simple on-off switch. So it doesn't have to be too sophisticated circuit. too sophisticated, because the speed doesn't matter, the saturation doesn't really matter, the maximum frequency doesn't really matter, because it's just on off, right? So it will be something simple, or perhaps it's one of these transistors over here, could be, because the output here will be open collector, the output of the ECM. So let's grab a multimeter and let's find ourselves a short. Let's do resistance mode. And we're gonna do the positive or the red probe here and just catch any ground. Capacitors are the easiest. And we have 17, 18K. 18K. Well, that doesn't make sense at all. That doesn't make sense at all, because the resistance is both too high and too low. It's too high and too low at the same time. It's too high to be a short, but it's too low to be a proper open collector. I would expect mega ohms or just open line. Actually, I would expect open line. But let's switch polarity. Does that make any difference? It makes no difference. 15K. 15K. This is likely not an output stage issue. Let's do this. Let's inject 1 volt into this rail. But first, let's find the ground. Reduce our current to 1 amp, just in case, but at 1 volt, probably we won't see any current flow. And let's see. Yeah, no current flow. Now we could inject higher voltage. Let's inject 5 volts. It is grabbing something. It is grabbing something because we have 14K. But it's not enough. It's not enough to actually turn on the relay. 14, although, so if the output stage is shorted and we also have 14K resistor, that would explain it. So our transistor, our output stage, is shorted to ground, but it's going through the resistor, 14K resistor. That would explain it. I wouldn't expect a 14K resistor on this line, but as I said, we're controlling the relay. There's not a lot of current that we need to push through. Well, only one way to find out. Since the board is consuming some current, let's just feed it and see what is actually taking that current. what do we have on the other side? We have transistors. And we have 11K. We have 11K resistors. We got it. We got it. That's our faulty transistor. So this is part of a recall. How did it happen? Because the Subaru recalled it. So the bulletin will tell you to replace the ECM, which will resolve the problem, obviously, right? But how did it happen? So the bulletin says that it's due to faulty relay, right? And how can a relay cause a issue like this? I actually can show you exactly how. But before I do, let me show you a beautiful spot. Because normally it's not that easy. Normally it takes a lot more. See the spot? I'm not sure if there's not too many reflections, but there you go. That's the spot. So, how did that happen? If you're curious, I actually have a schematic ready for you. This is roughly our schematic. Our V1 is our MCU, which controls this transistor that got shorted. This transistor in turn controls the coil, which is located in the relay. It's basically a coil. And all that is supplied with 14 volts from over here, right? Somewhere else. And we're controlling it with 14 volts. That's fine. That voltage actually could be even lower than this. But we need D1. Why do we need D1? So all the voltages over here, as you can see, oops, wrong thing, right? The current on the collector goes, well, in this case, to 180 amps, because this is perfect transistor. So obviously it's not going to be that much. But I wanted the current to be high to show you what happens. So here, from 14 volts, we just kind of drop to 0, then back to 6, then drop to 0 again, and go up, because our control signal is this, right? We wait 10 milliseconds, we turn on, and it takes 1 millisecond to turn on, which is like really long. It doesn't take that much, it takes microseconds. And 1 millisecond to fall down. And the pulse is roughly 10 milliseconds, right? So this is what we expect, right? Voltage drop over here, then spike, well, not spike, the unload, and voltage drop again, and back to the supply rail. Now, how can a faulty relay cause this is, oops, if we get rid of this diode, check out what happens now. See the spike over here to 45 kilovolts? That spike is right over here. 45 kilovolts. So you can't even see the signal because it's off scale so much. This is after the coil turned off. So after our 20 milliseconds, right? We turned it on here. It's good. We turned it off and we have a huge spike. And that spike, obviously, if we have kilovolts here, then this transistor will fry up. That's it. That is how it happened. Now, where do we get this transistor from? Good question. Good question. A few agonizing hours later. So this should show 10K, and it's showing 3.2. Well, the transistor is heating up as soon as we put some current, as soon as we put a few volts, 5 volts on it. So at 12 volts, it's gonna be red hot. All right, in either case, I don't have the resistor or the transistor in stock, so this will have to wait until I find the replacement. Either I don't know. I think I'll go with the used ECM. I'll just get the used ECM for parts and get them from there, because that's gonna take a lot less time. If I order it from China, that's like, you know, sometimes 2 weeks, sometimes 3 weeks, sometimes it's a month, and I don't know what it depends on. And at least if I get ECM off eBay, it'll be quicker. Also, well, actually, if I just, because I could just clone it, just get the same ECM and just clone it. It's roughly the same amount of work, although if you have to clear the VVT, then that's even more work. Plus, there's always stuff that can go wrong. So yeah, I'll start with the transistor. Anyways, I hope you were as bored seeing this as I was doing it. Nevertheless, thank you guys very much for watching. This was actually the first ECM that I had with a short. It's very unusual. Nevertheless, thank you guys very much for watching, and I shall see you in the next one.